So welcome everybody to our plenary session on ocean indicators. So I'm going to have to kill a few minutes now because Karina and Sam have just left the room. Our session on indicators is our work stemming from work package 3. So indicators act as this level above essential ocean variables. So the idea with indicators is that we gather up all the best produced essential ocean variables and that we elevate them to a level that they're digestible and accessible by a wider range of audiences, including policymakers and other stakeholders such as that. So to start off with, we've got Karina Von Schuckmann, who has been leading the indicators work for many years, and I'll hand over to Karina to give first presentation.
Thank you, Gerard. So thank you very much. So I will start with trying to talk about, let's say, a concept which can be called of narratives, and also with particular role on indicators into this. So first I would start with this question. I mean, we have discussed a lot about it, and this is just, again, a synthesis where we stand. Because there was, when starting with these activities on the indicators, there was, when you were looking into literature, there was not really a clear definition on what indicators are or what the criteria are, or also if you discuss it in the community, there is large inconsistency and not really clear what the use of indicators are and how to go forward. This came up then with this motivation to, even the IPCC didn't provide any definition in the glossary. You know, in R6 there is, but before there wasn't, also IPBES, etc. So that's why we have started under this activity, coming up now with definition and also with criteria, also relying on some other activities like GCOS, the Global Climate Indicator Framework, or the IPBES. So there's the Climate Convention. There's also an activity, not only for the ocean, but with the entire field of biodiversity. And so we come up with this criteria and the definition, which refers to a measure, which is based on scientifically verified approaches and data that allow for the identification of the state in the ocean phenomena and across a range of temporal and spatial scales for the scalability, and also which are accessible to inform decision makers and beyond. So wording accessible means also update and also accessible for the data and so on. So these are the different criteria in terms of verified, in terms of methodology, justified, in order to be useful for broad understanding, for informing, significant with a specific framework, including uncertainties we discussed, measurable to ensure that it can be determined from the frameworks which are underlying and having a lot of efforts in terms of defining the EOVs, ECVs, EBVs. And then scalable in space and time, so that we can discuss from global to regional and local scale and connect those changes. And accessible, again, following fair and care principles, and enable also the connection between the past, the real time, the near future, and the long-term future. So the optimal use, of course. So we started, so you know how difficult implementation is. So the reality of putting all these nice frameworks into reality. So we have started also to provide some pilot indicators so that we can start to work on this. Those indicators are at different stages. So we have also proposed an evaluation for the indicators to assess the reliability, let's say, status of this type of indicators, and to put also momentum to the community that we work on those and apply the criteria to demonstrate. And so these are the pilot indicators for physical, climate, biogeochemistry, and biology and ecosystems to start with. So it's not an approach to be comprehensive about these fields, but it's an approach to start talking about the indicators and moving ahead. So why do we need indicators? So indicators play a strong role of being a facilitator, not only within science, not only with respect to communicating the changes in the ocean to a body audience, such as also policy or wider public, but it's also a facilitator to enforce international multidisciplinary collaborations when it comes to narratives. It's a facilitator to talk about and create narratives on driving the observing system capacity, to forecast in the model, to link the different systems together, as I said before, from the these are different products, so from the past to the near future and so on, and the predictions and forecasts. Also, they are useful for the assessments and reportings. Very important also for research and development. As I said, there are different readiness levels, and this again highlights also the way where we should move forward for specific themes in order to be able to realize, for example, scalability and readability, or put the different products together. And of course, for the communication aspects, and also particularly at the science and policies here. So how can we further empower ocean indicators? So, and also essential variables. So that's not only indicators. I wanted to change the text, but so it's those information, the variables, but also the indicators pave the way to facilitate the transfer of expert knowledge based on different data to inform policy. So we have the variables, we have the indicators. So at each level, we put added value to go up into this chain and come up to the narratives, which would provide us the opportunity to also link to socioeconomic aspects with respect to the environment, which allow then also to further move towards, for example, informing policy. So this is just an example of a narrative we all know, we have heard already. I will not go further into detail, but it's just one example, and this is a more expert-related narrative, but also providing an importance for this. So if we see that the ocean is warming, we have seen the nice presentation from Audrey yesterday. So what do we know? We know that there are a lot of implications going on in the ocean. We know if the ocean is too warm, that we have a lot of implications, such as we have a decrease in uptake of capacity for CO2. We know that there might be stronger storms. We know that there is an impact with the cryosphere. We also know that there are a sea level rise, and then we have saltwater intrusion, coastal erosion, etc. So there are many aspects which we know just because this time series is going up. Then we also know if this time series is going up, so if it is increasing, we know that the Earth is out of energy balance. Also not going into further detail, but this is determining planetary warming. And also we could see with this time series that warming is accelerating. So it's just one time series which provides us a lot of information in order to help us also to act, and also to ensure that we raise the voice of the ocean, because the ocean is our sentinel for global warming. This is another work which is a pilot study, so this is really not yet in progress. It's just to start the dialogue. So the idea here is to combine indicators, different types of indicators in a simple way, together with socioeconomic data. So this is an example where we have used here data on indicators such as ocean warming or acidification or sea surface temperature changes for different areas. So we have used areas which have used in Copernicus Ocean State Report, but also have used areas as defined in WMO. This is the big gray one. The colored areas are the large marine ecosystems in order to stay in our science space and not go to the economic zones, so which are always moving also, so you don't know which shape to use. And we use here, and these hashed lines are the areas, and the points are the areas where the heat content or also the acidification is rising faster than the global average. So very simple without adding some difficulties. And we combine this with different information like aquaculture production on the countries. This is from MHWs data, and also we have in brown the areas of finfish, and also for the boundaries for UNESCO World Heritage Marine Sites. This is just an example where we can start to put this different information together and create based on this different narratives. So we are proceeding also with other aspects. So just to start the dialogue of what we can do. Yes, so with this, I would like to go on a very important topic, that is the regionalization of indicators because there are a lot of challenges of them.
Hi. So for those of you who don't know, I'm Samantha Hallam at NUIM University, and this is talking about the challenge of the regionalisation of ocean indicators and the proposed approach. So this is work with Catherine and Gerard, and obviously a lot of you who've been involved in task 3.1 through the meeting. You can't hear me. Is that better? Okay, thank you. I'll speak up as well. And then obviously this is in conjunction with obviously a lot of you in 3 and 4 as well. So why do we need a regionalisation of ocean indicators? So to look at the unique patterns in different regions, so obviously the warming cold, for example, in the North Atlantic, also looking at the regional trends compared to the global trends. So for example, why is Ireland warming at a much slower rate than globally? That will then help us to isolate the mechanisms and the drivers. So is it related to air-sea heat fluxes, or is it ocean affection and a slowdown in the AMOC potentially? Which will help us inform and provide stakeholders with the data to develop policies to address local challenges. But one of the challenges also is that remote regions have far-reaching impacts, as we're all aware. So for example, a slowdown in the AMOC will alter European weather. A warmer North Atlantic can lead to changes also in European weather, but also in marine biodiversity. And the melting Arctic sea ice obviously changes the atmospheric circulation pattern, causes more extreme weather and shifts in climate norms. And the Atlantification of the Arctic leads to changes in Arctic ecosystems and ice cover. So do we need a local or a remote ocean indicator? Can depend very much on the question that we're asking. As Gerard was talking about a day or so ago, why is mussel condition changing in Ireland? So for that, potentially the indicator that we need is the local Irish changes in sea surface temperature may be the best indicator. But then if we're asking why are air temperatures in Lithuania rising faster than some other European country, then we may need to be looking more remotely at the changes in the Arctic sea ice and the North Atlantic temperature changes, which may be influencing the atmospheric circulation, the jet stream pattern, leading to warmer than average temperatures. And certainly from my perspective, looking at hurricanes in the North Atlantic, we may be looking at a local and also a remote changes. So for example, how active would this hurricane season be? We will look at the temperature changes locally in the main development region in the Atlantic, but also looking in the North Pacific at the El Nino conditions, and do we have a La Nina, which will then lead to weak vertical shear over the Atlantic, which would then drive a more active hurricane season. So I guess the question is what is the question you're trying to answer? So in terms of trying to agree the regions, we're looking at what is the EOV that we're looking to analyse. So this has been specified as part of obviously for CLIM. So for task 3.1, we're looking at sea surface temperature, sea surface height, sea ice and subsurface temperatures. So from that, we're looking at what are the proposed indicators we're planning to use, which Karina's just outlined in a lot of detail. So and from there, we've gone to what are the proposed regions we're going to be looking at. And so taking it from globally, looking then more regionally, then looking at the seas, and then looking at specific case studies, and then also some thematic regions. So that's how we're doing this regionalisation approach. And I think as Jay was saying earlier, trying to keep the methodology the same so that actually they're all comparable across the piece. So for EOV1, sea surface temperature, this is the proposed approach. So what we can see over here, these are the proposed, this is currently the proposed indicators. Now, not all of these will necessarily survive So this will be down to what's happening obviously in work package 4 in terms of looking at the uncertainties. So obviously where we are now at the moment is saying these are the proposed indicators that we put forward in the milestone 6 report, and then it will be as part of as the ongoing work goes on as to whether these will survive as the proposed indicators. So if we take sea surface temperature, which is obviously more mature, we're looking at that in terms of the satellite data, but also observational data. And the plan is to look at it globally, but then also for the whole North Atlantic, but then looking at the northeastern Atlantic and the adjacent seas, and then moving to the specific sea areas. So you've got the Barents Sea, the Nordic Sea, IBI, which is Ireland, Biscay, and Iberia. Then we've got Baltic, Black Sea, and the Mediterranean Sea. And then we have the specific case studies. So we've got the Finland EEZ and the Irish EEZ, and then the territorial waters also around Ireland. And then we are looking at 2 thematic regions, which is the Gulf Stream region and also the main development region for hurricanes in the Atlantic. So then in terms of ice surface temperature, which obviously Pia talked very nicely about yesterday, that will be in the Arctic and the Antarctic. And then also planned at the moment is melt days and freezing degree days. So then moving to EOV2, which is subsurface temperature. The key indicators there are ocean heat content and also marine heat waves. The planned and obviously the work being undertaken is predominantly as part of the other work packages, so it's either in work package 3 or work package 4, and this indicates the institute which is undertaking the work. So again, it's very much similar in terms of the regions which will be looked at, and the plan is that the way the regionalisation will work will be trying to use the coding and then using the specific shape files so that we've got a similar methodology across each of the regions so that they will be comparable. And then sea ice. Sea ice, there's a lot more potential indicators at the moment, which is obviously part of the evaluation process that will be undertaken as part of work package 4, where we've got the areas of the Arctic and the Antarctic, so looking at sea ice concentration, drift, thickness, age, area, freezing date, breakup date, sea ice volume, and open water days. And then in terms of the data, so a lot of the data is going to be satellite data, but there's also buoy data going back to 1979, but also in situ observations from FMI, which go back to 1898. And then the final EOV under this that we'll be looked at will be sea surface height. And there the proposed indicators are sea level, so looking at mean sea level, then the mass component of sea level, and then in situ sea level, which is around the tide gauge data. So again, it's going to be looking at, in this case, we're going to be looking at the northeastern Atlantic and the adjacent seas, again, each of the sub-regional seas, and again, the case studies, again, around the coastline. So that'd be national and regional coastline. But then, as you can see, there's some quite specific work in terms of the tide gauge data, which will cover the Norwegian coast and also the Arctic Ocean. So, in terms of a one-page summary of what the regionalisation of ocean indicators is going to be looking at. So those are the 4 EOVs, and those are the potential indicators for each of those EOVs. And those are the various regions that we'll be looking at, going from the large scale down to the much smaller scale, which will hopefully provide us with more insights on the temporal variations of the regional indicators, the underlying certainties, and hopefully then enable us to look at more of the drivers behind what the different regions are called, behind each of the different regions. So thank you. If you want to read the milestone 6 report, there's the QR code. Thank you.
we're not all sick of marine heat waves by now. It's been mentioned quite a lot. We had our own session. But I have a few moments now to talk about marine heat waves as a demonstrator for a cross-cutting ocean narrative or indicator. And I think in this context, cross-cutting can mean a few things. I think what's in mind is the fact it crosses across disciplines, applications, stakeholders, but of course also in terms of spatial and temporal scale as well. So on the pathway to defining indicators, or as you'll see, maybe a framework for extreme indicators, we organised a marine heatwave hackathon, which took place earlier in the week, with the aim of providing perhaps some recommendations or some sensitivity analysis on the, as we'll see, competing definitions for marine heatwaves. So we'll get to that. But first of all, let's begin at the beginning. So it was perhaps long been understood that not only extreme temperature, but prolonged extreme temperature has certain impacts on biology, ecosystems, biogeochemistry. And it wasn't until 2016 that the now famous Hobday paper provided a framework, formalized this definition, as I say, with this framework, but they also offered recommendations for the precise setup. So saying that the threshold should be based on a 90th percentile of SST based on a 30-year period, and that marine heat waves should only be considered damaging or important if they have a minimum duration. In this case, they chose 5 days. And in the past 10 years, most papers have run with that framework, but also have not changed much those precise values, although there are some important exceptions, as we'll see. And then later on, we have these kind of hurricane-style categories defined. You can see at the bottom right the how far above the threshold your temperature is, which is an extra metric of relevance for users. Recently, it's becoming apparent that there is no universal definition, let's say, because you can play with your percentile threshold, your baseline, your minimum durations, even the type of baseline you're using. So there's lots of these papers and comments which are discussing these different techniques. And essentially, they're coming to the conclusion, in fact, there was a paper two weeks ago saying we need context-specific methods. There's perhaps no universal approach, no one-size-fits-all. So a bit like Snoopy at the top there sitting on his roof, there's a bit of an existential crisis going on. What does a marine heat wave want to show? What does it want to be? And it can be many things. For example, yesterday we saw Vera from FMI presenting their work on a 200-year time series of marine heat waves. The results you see there will be very sensitive to the setup, and can say both that marine heat waves are increasing with time or are constant if you're changing your baseline with the years, which is confusing from a communication point of view, but scientifically true and relevant data. So we have this issue, let's say, this complexity, and that's why in Milestone 15 last year, we, on the identification of extreme events, we, let's say, promoted flexibility in this approach, given the amount of types of studies of marine heat waves being done here, projections, historical data, looking at the impact of climate change, etc. So we promoted flexibility. So I might be about to get into quite a technical talk, but the aim here is to really get to the nature of the marine heat waves, to the heart of the matter. And I think these points are kind of the motivation for why we're doing what I'm about to show you. So indeed, we've got this cross-cutting indicator for many potential stakeholders, many different needs. And there was already a comment yesterday saying, if you're in that specific area at that specific time, talk to a specific stakeholder. Absolutely. There is perhaps no universal approach, and perhaps we should be thinking as a WP and a project to provide a framework for definitions. And then we have to ask the question, what's the difference between these extreme indicators for climate and specific ecosystems? We are OBSI for CLIM, not OBSI for specific fish farm off the Norwegian coast. So there's a compromise there we have to find, let's say. So I do ask myself, can this classic approach that everyone's been relying on provide a kind of proxy for more specific marine heat wave indicators, which can be built later on with specific stakeholders? which is of course itself, even with one stakeholder, a massive task. And should some genius come along in the next few months or years and provide a new physical mechanistic definition, great, we will have something to compare to and challenge. At the moment, I'm not seeing it, and I certainly don't have it. So taking a kind of pragmatic approach, we get onto the hackathon. So the aim here was to learn, as a good hackathon should be. We had a range of, let's say, career levels attending, from PhD students who just started to senior scientists. So it was a great way to share information. I guess the scientific objective was to explore the role of the marine heatwave definition on our understanding of the characteristic behaviors, the trends, and on individual event descriptions, which in various ways we hope can justify the future uptake of marine heatwave indicators by, for example, Copernicus. In numbers, we have, prior to the hackathon, this is unusual for a hackathon of 2 days, we created a data set of more than 2 terabytes. There was a 4.5-hour time difference between us and Saladi, who was participating in India, who stayed until late in the night. 6 case studies, more than 10 different experiments, 17 participants, currently 30 slides of results and growing, but we'll need to get the story out of those yet, and 42 years of high-res SST data. And that's the visual representation there of what intense concentration looks like. Stefan and Sabrina walked in at one point and were quite alarmed by how serious we were. So I don't think I can do justice now in 2 or 3 minutes to the effort that was put in, the amount of discussions we had. But it was a wonderful event, and I thank everyone for their participation. And it should be said, for this data set, Alex and Nishka from DMI put in a massive effort to get this ready in time for the hackathon. So this is the first main output, let's say. It's a data set based on the Ostia SST product, high-res, daily, 42-year data set of marine heat waves based on a range of definitions. So 2 climatologies, one the WMO recommended, and one is more in line with some of the Copernicus products, so reanalysis or seasonal forecasts. 3 thresholds using detrended SST, different minimum durations, and we have as output the SST anomalies and the marine heatwave categories. And for certain years and case studies, we run the whole combinations of these different parameters. So we have something like a dozen or so different combinations there. What's the relevance of that? Well, we think it's to provide users and scientists potentially with a build your own indicator, so they can choose pre-made marine heatwave definitions, which could in theory be incorporated into some sort of indicator portal, whatever that may be. It allows us within the project to test the robustness of our work on drivers or projections to the different definitions. And as I say, if a new definition does arise, then we have a benchmark against which we can compare. What does that actually look like? Well, this is many results here. Basically, at the top, you have 3 marine heatwave statistics, let's say. That's the percentage of marine heatwave days in the record for different thresholds. So 90th to 95th to 99th. What we're seeing there is not surprising. As you go from the 90th percentile, you get about 10 to 16% of the record is a marine heatwave. As you knock that up to 99, it goes down to 2 or 3%. So you're filtering out the rarer events. And then we have more complex findings, let's say. I will zoom ahead to show you the differences. First of all, we've identified where detrending makes the most difference to marine heatwave identification. At the top is showing the difference in the percentage number of days detected. So green is showing that when you detrend, you get fewer marine heatwave days on the record. That the implication is, of course, that non-linear warming because of climate change is contributing to those marine heatwave days. More complex response is perhaps at the bottom, when you take a climatology period within a longer one, so you take a shorter one, like the so-called reanalysis period, and what you do then is you remove certain large-scale events like El Nino, which happened in 91, 92, greatly affecting your climatology, and you see this more complex response to the sensitivity of marine heatwave statistics. So if you're doing a driver analysis or something, you've got, a different number of days, a different record in theory. So that's quite interesting, and we need to explore that. This is, I'll try and wrap up quickly here. This is an indicator that a graph we might see in, for example, Karina's State of the Ocean report. This is the percentage of surface ocean covered by a marine heat wave for the various experiments. This is important because it's something that might be picked up by the media, for example. It's one of those statistics that is used to communicate, and there is indeed a great variability in the magnitude. Of course, the interannual variability and the long-term changes aren't greatly affected, but indeed the magnitude is. Finally, and again, this is a bit more of a technical point, but again, we're talking about recommendations for people setting up indicators, so we think there's something interesting here. On the left, for 3 different regions, we have various categories of marine heat waves, so the area of those regions with different categories. For left, the 90th percentile, right, the 99th. And what we found is that when you look at the higher categories using the 90th percentile, information is very similar to the information from the 99th percentile. So we're asking the question, do we really need to consider other percentiles? Can we just not look straight at the categories? Which is also something more intuitive, I think, for scientists and users. And again, there's a whole heap of plots on specific case studies looking at spatial extent, onset timing, and their sensitivity to these setups. And there's a whole lot more than what I'm showing here. But I will finish up. Thanks for being patient, listening to the short snippet of the results from the hackathon. But I will leave these key questions and discussion points up. And thanks for your time.
So, so what I maybe invite the 3 speakers to come back up actually. We can have a few questions for the last few minutes of the session.
Thank you very much for all the presentation. It was really very interesting. So it is a sad day today because we have just heard that the US have decided to not communicate anymore Argo data, so the US Argo data. So this for science and science of climate is really a bad day. Concerning the marine heat waves, so there is, of course, this is a very important part of C4 Clean, but there is also a kind of large community outside. There is a CLIVAR focus working group. There are also groups trying to develop regional observance system. So would be nice to perhaps organize a small workshops because what you came out with, starting to come out from this hackathon, there are some questions, of course, that comes out regularly also from the Ocean State report. So maybe we should, if possible, to organize something to try to converge. I don't say that in the next 6 months, but at some point.
Okay, agree with that. Yeah.
So thank you for the very clear presentation. So I liked a lot the idea of having a portal, maybe because that's also implicitly giving an important message, which is stopping using standardized, stop aiming for a universal definition, because the problem doesn't make sense, not for the physics, probably not for the application. So I think it's great. That's a good path. Someone will go there and maybe one can help the user to say, depending on what you're doing, may make more sense this and the other. So that's I think is very good because move the focus finally. And the other one is, but then on the technical part, I think one important thing is you have to consider the minimum day. It's crucial because I've seen the sensitivity you've done. And, in a year, when you look at the frequency of marine wave, basically that's heavily skewed on the short marine wave, because how many marine wave of 200 years we have per year? Probably 0. But how many of 6 days or 7 days? So basically, I noticed doing some sensitivity that obviously it's kind of follow a power law, okay? And so what you want to do is you want to explore that because that's very important. You can have I've seen some analysis that you can change the question is what is the hot spot on marine wave in the Mediterranean? Well, the answer depends on that minimum day. The Alboran Sea example becomes a hotspot with 5 days, but not with 14. So, and that's arbitrary. So that I think is a very important sensitivity that maybe you can add. That's all.
We only added 5 and 10, but arguably we could find another way of filtering.
Yeah, but it's a very good, I think, it's a good approach.
Thank the three of you for really good presentations. The measures of the heat waves, one would ask whether it's really the change in the chemistry and more important perhaps the biology of the ocean in a particular area of a heat wave. And if that's a lot, then the metric of the heat wave becomes more interesting. Have you given any consideration on that?
In terms of compound events?
In terms of compound events, but also on the other disciplines, the biology, for example.
Is that something that's elsewhere in Work Package 3, compound events?
Yeah, there is. Yes, there is something in the task 3. You start to look at the emergent, but it's more long term, not the extreme. So maybe on the compound extreme scenario.
Okay. Well, I know from speaking, I think to Abed yesterday about the new sister project, they are also keen on indicators. So there is a chance there, I think. I'm not sure if you're looking specifically extremes, maybe so, but there's a chance for, I guess, a communication between projects. Because we often think about, let's do some sort of impact study of marine heat waves. But many impacts are kind of, as you say, not just related to temperature, but there might be existing stressors, which temperature just helps push over the edge. We might not have the expertise on that. So indeed, we need to take our indicators here and combine them perhaps with some of these new bioeco-ocean ones.
Just to add, I think this is a good example of, again, narrative which can also cross-cut across the 3 projects because marine heat wave, CO2 uptake, marine heat wave, economy, ecosystem, etc.
Yeah. Thank you very much. Yeah, I was also thinking, and it is something we discussed yesterday with Justina, that you have 2 projects now, MIRE and CICLIN, which are starting and really doing this regionalization of indicators, and they're running a lot of models. So I think it's going to be very useful if you can provide them. They were really wondering about the special and the temporal resolution of their models. So I think you should connect with them and see how we can work together. And you have quite a few I think DMI is part of these projects, and Atlantic Plus and different partners which are part of the project, so we have a good connection.
Thank you. That sounds quite helpful to do that. And as Ronan was saying, the idea is that typically we will have some kind of portal for the indicators. So they're actually a portal for the indicators. I think this will hopefully be just one to start with of this result. So actually seeing if we incorporate other projects as well would be quite useful.
And actually, we will start to have a discussion over package 3, so tomorrow, and for CICLIN. So for the other project, we have to explore. Thank you.
Yeah. Regarding the policy side, so I was wondering, when you create an indicator like regional warming of Irish Sea, then what really is the policy side? Yeah, you can of course see that it's getting warmer, but if I would be a policy maker, I would think about what can I do against it, right? It's
sure, you need to present the evidence, but the question is then what to do. And there are, of course, mitigation activities you can do, so whatever, right? But you can also think about, about real causes of that warming. So the warming itself, of course, is just an observation, so to say, that is confined to this indicator. Like you often see it with NAO, NAO is an indicator, and then people say, well, that's now correlated to NAO. Yes, but I mean, why is it? Is it now NAO also is something that has a cause, that there's a reason behind the NAO, and that's actually the real interesting point, I think, to understand, and also then to find ways to mitigate the effect of exactly the reasons for creating the NAO as it is, or warming the IRC. So I wonder how you position that.
Yeah, and I think that's really a key part of it, because obviously, for example, if you take like the Marine Institute in Ireland, we have the global warming increasing, and then we're sort of looking at the buoys off of Ireland, which are showing coolings, for example. Then there's this whole question of the consistency, which is why, for example, the stakeholders in Ireland would want to know that. But as you rightly say, that then goes back to why are we seeing that? So obviously, if we've got the warming pole and there's potentially the slowdown in the Gulf Stream, but it also could be associated with the heat fluxes as well. But then, as you rightly say as well, it's not just the NAO, but it also is potentially then linked back to changes in sea surface temperature, potentially, and with sea surface temperature gradients in the Gulf Stream region, which is why we've picked one of that as a particular thematic region, which may be important in terms of helping us explain the drivers behind it.
Quickly, also something. Yeah, so in addition, I think it's also important, targeting policy can be very wide-ranging, so it depends also what type of policy. And this type of information, for example, for temperature, as an example, it's important to know if you want to implement any sustainable action, or if you want to implement also adaptation plans. So you need to know where the ocean is changing and how it's changing. This can be sea level rise, but that can be also regional patterns of surface or subsurface temperature. So depending, for example, for food security, so where you put your new aquaculture sites and you don't put it in areas where we have a hotspot of warming, or where we have maybe more variability, etc. So I think these are relevant information. So it depends also on the target of policy. And
yeah, it's just a comment and not a question. And in additional information regarding this project that you mentioned, there is a further one that has just been, recovered. Yes. So there will be also another project providing downscale projects in the Mediterranean, in the Black Sea, and the Baltic region. And again, regarding this, very potential importance of the interconnection between projects, I think, and I deeply support the idea of having the marine waves as sort of, case study, as a prototype to make connection with bioclim and the next project that will start soon, because that's a perfect example of, having phenomena that are really interconnected between the physical and biogeochemical world. And in that sense, I think we should come up with something agreed with the Commission to try to come up with something that is recognized as a product, as a deliverable between the three projects. Okay, it's not just scientific collaboration among people who got to know each other during this wonderful meeting and so on. But let's try to formalize a way to to say, well, these are the three projects, and this is something that really come out only because there were all the projects together working.
It supports the communication.
Yeah, I would like just to jump on Simona's comment. Actually, it's very, very important. And here, I was interested by the pilot study that Karina has. So you showed combining ocean warming with ocean acidification and socioeconomy. And this is the first time I see it. We were talking about it a lot, and it was really nice to see it. So what type of socioeconomic parameters are you taking into consideration in this pilot study, like GDP? What type of metrics are you putting into this indicators? That's gonna be something very nice to collaborate on in the hopefully next project.
Yeah, so as I mentioned, I would like to highlight this is still really pilot, so we are really experimenting around. So uncertainties are missing, we will add them and so on. So that's what we are doing. We are exploring for the moment what type of data are available, also with respect to reliability, right? Because I mean, it's a different expertise. And the plan is then to establish first drafts of this, and then to go and partner with experts to do a co-construction, because I don't have an expertise on these socioeconomic aspects. Of course, I can look for having reliable, trustful data sources, but nevertheless, I mean, how it is. Even if I choose a heat content product, maybe others would scream, "Oh, don't use this one," and so on. I mean, it's important. So that's the idea, and then start to co-construct and engage and put experts together. So. But I think you need to start with something, not from a white page. And so we look at some themes. So we start to follow up because there's a bit of this constraint for the region, Europe, and also global. And for the global, we try to align with international policy. Like, for example, we try to allocate data where we demonstrate the triple planetary crisis, on one map. Like, we look at how much plastic is going from the countries in the ocean and this kind of things. We started BBNT, where we look at how many areas are already under marine protection and so on. So, but again, it's a start, and we are aiming for then co-constructing. So I don't want that this figure will be distributed because I'm ready, but it was to start the dialogue and also to see who's interested to collaborate and to create these partnerships. So it will be a big joint activity.
Very final question here, and then we really didn't have much.
It's not really a question, just a comment from an atmospheric point of view, for example. When I think about a product related to marine heat wave and how this product could contribute in the atmosphere science, thinking about forecast. When I have a product with that demonstrates a great source of heat to the atmosphere, it's something that we keep an eye, because there is a potential situation to start some storms. So we had a great example, great but not that great in terms of protocol and society. But for example, for the meteorology, we saw last year a huge storm in Spain, most of them developed over the sea, and we had some marine heat waves that happened in that area. So it's a great source of energy to the atmosphere, and in terms of impact and early warnings, for example, you have some information, previous information that you can work on with and increase the probability of the forecast be assertive. So you can use this information to move some society or to do some security things over land. So it's just a great product. Yes.
I can give to you, Karina, but to me it sounds like an excellent idea, example of a narrative almost. And it helps us define maybe in a specific region a marine heat wave indicator that has a specific use, storms or tropical cyclones, hurricanes. That's something we should consider.